give you guys too much, but kind of the same format we had before, where we have one section and then you do the homework and you do the next class period. We only really have chapter 11 left. So we have 11.1, which is we're going to talk about today. We have 11.2, 11.3, 11.4. So, and then we're done. And we'll have like a little assessment on that, on the stuff from chapter 10 that we talked about before break. And then, excuse me, chapter 11. I heard today, and I guess it's no big secret, there are no final exams.
Wait, really?
Yes. I just got an email this morning, and I'm sure it'll be going out. They are giving the teachers an option to do like a final project, like that. So I think what I'm going to do, I'm going to think about it. I haven't really finalized it yet, but I want it to be something more fun, more creative, something that's, not something when you have to have your nose in the ready for. It'll just be a lot more fun for us to share together during that last week. Does that sound good? So I haven't really figured it out yet, but I will, and I'll let you know. So we are able to do those types of things in lieu of having exams. So that's something to look forward to, okay? All right, so let's talk about 11.1, okay? So I posted the key to the notes online. So go, if you go under topics, 11, go to 11.1 notes key. So you can pull that up, compare your notes to that. I've worked out all the examples on those notes as well. So that'll be something good for you to have for some other little assessments we'll have a little bit later. So if we have any questions on the notes themselves, I'm going to share my screen and pull those up. Okay, can you guys see the notes? So the big thing for this section talking about, obviously you know about circumference of a circle, so hopefully that wasn't anything new. But the big thing that was worked out through this whole thing was arc length. And so arc length is basically just a piece. So if you look here, arc AB, it's actually just a piece of the circumference. So if I were actually to take that piece out and make it a straight and measure it, that would be the arc length. But it's basically just a percentage or a piece of the entire circumference of the circle. And so the formula is there, and there's different ways to manipulate the formula. But as you can see here, and if you think about it, it kind of makes sense. So if we look at the second formula, the arc length of AB is equal to the measure of the arc over 360. So that's basically giving you a percentage, like what percent is this arc out of the whole circle? And then multiplying that percent by the circumference because it's arc length, okay? So it actually kind of makes sense in the grand scheme of things. So any questions that I can answer about the notes? Anyone?
I had a question for, well, 10, and then also, yeah, so 10, and then also 15 and 16.
Okay. Yeah, 10, it might have been hard to see in the notes, but what it was asking of the shape, so that means obviously the side. So if you look at my notes here, I did 11 plus 11 plus 41. It's kind of hard to see the one there. Plus 41. So I added all those together. And then I had to figure out basically the arc length of each of the corners because they're not straight corners. So if you look about it, there's 4 corners, right? If you think about that as like a sector, if I have 4 pieces, doesn't that make up one circle actually? So if I think about it that way and find just simply the circumference of this circle right here, because they're all the same circle, the circumference is, well, 11 was the diameter, 11 pi. So the circumference of like one of these little circles is 11 pi. And because I have 4 corners, it makes up the entire circle. So 11 plus 11 plus 41 plus 41 plus 11 pi. And that would make up all of those corners. So if I want an exact answer, I would just say 104 plus 11 pi, or I could actually turn that into a decimal, which would be the approximation 138.56 pi. You could even multiply it by pi to get another decimal approximation if you wanted to. Does that make sense? I know it might have been hard to see. You're like, okay, what part of the circle am I looking
Yeah.
at? Yeah. Hopefully that makes more sense.
Thank you.
You're welcome. And then you said 15, Labe?
15 and 16.
Okay, so if you look here, 15 was asking you to find the measure of arc EHF. So here before I got really started, I went ahead and figured out the measure of each one of these arcs, hence the central angle. So 80, 80, and then 200. So arc EHF would be 200 plus the additional 80. Does that make sense? So that gives me 200 degrees for arc EHF. So because I have that measure, I can actually, let's see, hold on. 16 actually doesn't involve that one. Does it? FEG? Well, FEG is the same measure. It's 280 as well. So to find the length of FEG, so FE all the way around, so that whole arc length, I'm going to use 280 degrees divided by 3 times 2 pi times 7, since 7 is the radius. And then I just simplify, and I can either leave it as 98 over 9 pi or multiply it out and get 34.21. So I tried to work out examples in the notes as best I could. Looks like I need a new pencil. My pencil is light, but okay. Does that help, Lay? Does that answer your questions?
Yeah. Thank you.
You're welcome. Anything else from the notes, guys? Okay, going once, going, they were kind of short. Okay, so I'm going to stop sharing there. And I'm going to pull up, I'm going to start sharing the homework problems. Here we go. And I didn't put the answers on there because I kind of wanted you guys, whatever questions you have, see if I had some volunteers to come out. If you can do that on your whiteboard, if you share your screen. So looking at one, I did put the answer for number 2 on my flip chart here. So that was kind of important to be able to describe the difference between the arc measure and the arc length of AB. And this is a really good explanation, if I do say so myself. But arc measure is the number of degrees of a circle that the arc is bounded by. And then the arc length is part of the circumference of the circle that the arc occupies. So arc length and circumference go hand in hand. All right, do we have any questions 3, 4, or 5 that need to be worked out, or anybody wants to check their answers? I can tell you what the answers were. We good on those?
Can you, you're 3, 4, and 5? Never mind.
All right, we're good with those? Okay. All right, what about 6, 7, 8, 9, 10?
Wait, can you do number 8?
Number 8, okay.
Can you also do number 10?
Okay. All right, do I have any volunteers to do number 8 or number 10? Anyone?
I can.
Who said Sandra?
Yeah, I can try.
Okay. All right, so I'm going to stop my screen.
Okay.
And then
I don't know if I
Sandra-
did it right, but
okay.
we can try.
Henry, did you need to see 3, 4, and 5?
No.
No, I did not.
Okay.
Well, we just had to find the circumference, right?
Yeah.
Well, you have your sorry for my bad drawings. Well, this was 14, so that means the diameter of the circle is 14. So the circumference would just be 14 pi. Right?
Yep. And then unless it asks you, when it asks you for an exact answer would be what Sandra just put up there, 14 pi units. But if it doesn't ask for an exact, multiply it out and give a decimal answer like Sandra's putting up there now, 43.98. Yeah. So when it says exact, it wants you to include the pi in your answer. And when it doesn't say exact, you can actually give me a decimal. Okay.
Can I erase it?
Anybody want to do number 10? Come on, guys. Anyone? Come on. Nobody wants to do number 10. Okay, I'll do it. All right, let me share my screen. You put my coffee down. Share. Can you guys see it? We're good? All right. All right, so it's asking to find the circumference of the red circle, so the one on the left. So if you think about it, to find circumference, let me get this. Circumference is pi d or 2 pi r. Do we know the diameter in this picture? Do we know the diameter of each circle is the same. Both those circles are congruent circles. Do we know the diameter? If all the way across for both is 10, what's the diameter of one? Sandra? I thought you had your hand up.
Sure, 5.
Yeah, it's 5. So all we have to do is plug in 5 for diameter, and 5 pi would be our answer, or that would be the exact answer. Or if you want the approximation, 15.71 units for that one. All right. All right. What about 11, 12, or 13? Anybody want to see those worked out? That was just finding the length of arc AB using that formula.
Can you go over 11, please?
11? Yeah. Do I have any volunteers first for that one? Going once? All right. Guys, we're gonna have to start like being more interactive and doing some of these, but
I control.
Just for today, I will do it. Okay. Speak up if you want to do it.
Isn't AB 40?
For number 11,
Yeah.
is it 40?
Yeah.
No, this is actually for asking for the length of the arc.
Not the angle.
It's not asking for the angle measure. It's asking
Yeah,
for
I
the
just
length.
realized that.
So for this one, number 11, I'm going to use AL for arc length. Arc length of AB is going to be the measure of the arc. So that's where we're going to use the arc measure out of 360 times the circumference. So I know the measure of arc AB is 40 degrees out of 360. And then I know the radius is 6, so I'll plug that in for 12 pi. And then I can simplify 40 over 360 is 1/9, whoopsie, times 12 pi. So I get 12 over 9 pi, which is 4/3 pi. If we want an exact answer, or an approximation would be 4.19 meters.
Oh, I got that.
So, but I think for all of these, because it didn't say exact, you can give me just the decimal answer for that. So you really can just plug that whole thing into your calculator, hit enter. But always be careful though, like if it says exact, it wants you to do a simplified fraction with pi. Okay. All right, 12 or 13? Okay. All right, so we have 15. This was very similar to the notes, this one. All right, 15, 16, 17. Do you guys want the answers and then see if you have questions? I'll put the answers on here just in case. So I got the measure of if you see my forehead. Arc QRS is 300 degrees. Number 16 was actually asking for the length. So I'm giving all of these as approximations in feet. And then the measure of arc QR. What number is that? 7. I'm losing my place. It's 150 degrees. The measure of RSQ. Number 18 is 210. The length of arc QR, I got 20.94. And the length, the last one of arc RSQ, I got, I can read my notes right, 29.32, is that right? Okay, any questions that I can work out on any of this?
Number 16, please.
Okay. All right, so number 16 is asking for the arc length of QRS. So it's asking for QRS here. And so we know angle QRS is 300. So arc length. I'm going to take the measure of the arc, 300, out of 360 times 2 pi, and the radius is 8. So I have 300 over 360, 16 pi. Now, in your calculators, whoops. I don't know how that happens. There it is. You guys still see? Okay, sorry. Okay, you guys still see my screen? I had a little oopsie. Okay, so if you pick up your calculators, you want to make sure you put that in parentheses and that in parentheses when you do it. So 300, because it's not asking for an exact answer, you can do that. And you should get, when you put that in your calculator, 41.89.
Miss Witcher,
Yeah,
do you want us to use that formula or the other one, the length over?
you can, whatever, I can use this for arc length. You can use this one, but you can use either one because they're the same. They're just manipulated a little bit different. So because you can see one of them actually has, you know, the arc length divided by the circumference. And then this one, because I'm trying to solve for arc length, it's more direct.
Oh, okay.
But they're both, it's the same exact, they're both the same. It's just the circumference in one of them, you're actually dividing it into the arc length.
Okay. I just used the other one, so I wanted to make sure. That was
Doesn't
okay.
matter. This one, I think, because I'm actually trying to find the arc length, it's just actually, I just plug and chug. I can just plug it in and don't have to do any more work after that. Okay. Any other questions on 15 through 20? Okay. All right. Last three. Let me put the answers for these. Number 21. These were had a little bit more algebra to them. And this is where you probably could have used the other formula depending on what you're trying to solve for. It really just depends. Approximately 15.02 degrees for 21. 22 is asking you for circumference, and I got about 35.53. And then 23 was asking you for the radius, so I got approximately 8.58. Any of those three you need to see worked out because those were a little bit different. You had to actually, you were solving for something different, but using the formula. A little bit
Can
more
you do
algebra.
22?
22, okay. Anybody need to
Can
see
you do-
another one?
Can you do 21?
Okay, 21, 22. All right, I'll start with 21. All right, so this one's asking you for the arc measure. So I actually used, about earlier, I actually used where I have the arc length divided by the circumference. So I said arc length is 8.73. divided by the circumference. And so I know that the radius is 10, so then the circumference is going to be 20 pi. And then that's equal to the measure of the arc solve for. So you can put x there or just leave it as measure of arc AB over 360. Now, once again, ask you for an exact answer, you can just give me a decimal. So what I'm going to do here to get the measure of the arc by itself, multiply both sides by 360. So that cancels out. And then I can simply do 360 times 8.73 divided by 20 pi. Hold on a second. That doesn't seem to work out. Hold on. 3 divided by. Okay, there we go. And you should 50.02. You can divide 8.73 by 20 pi first and multiply it by 360 either way. So that's number 21. Any questions on that one? And I'll be posting this video on the Walker web, so I know I'm erasing it now, but you can always go back and look at it. Okay, so let's do 22. So 22 is asking you for the circumference. So you can really use either one of the formulas. So basically what I did is I used arc length is equal to the measure of the arc, whatever the arc's name is, divided by 360 times, and because it's asking me for circumference, I don't have to really put the formula. I can just write circumference, or you can put an X there if you want. Okay. I know the arc length is 7.5. The measure of the arc is 76 divided by 360. And here I'm just going to use circumference. Now, in order to get X by itself, I have to multiply by the reciprocal of this fraction. So I'm going to multiply by 360 over 76 on both sides. So this would become 1, and then I have X is equal to, and then in your calculator, you're just going to do 360 divided by 76, and then multiply that by 7.5. And that would be your circumference. Anybody need to see 23 worked out? Okay. Great. Awesome. I'm gonna stop sharing that. Okay. All right, guys. Let's and all the notes. So what you have to do for today, some of you have already done it, and thank you so much for that. Go ahead and send me a picture of your homework. Do that by the end of today. You should be able to, hopefully after going over this today, go ahead and finish that homework and just submit it to me, and I'll give you 8 points on in the grade book. So just a quick question. Is it easier, like when you saw the news post today for our class, was that easier way of seeing everything that's due when you get that notification? Thumbs up? Was it pretty clear? Okay. All right, awesome. Do we have any last minute questions on 11.1? Okay, so I won't see you guys again until Monday, but on Monday we're gonna go over 11.2 format, but we will be doing a little Kahoot challenge. It's not gonna be a Kahoot game, like a live game, but it'll be a Kahoot challenge game. And we're actually gonna have you do that during this time. Okay, we'll put all ourselves on mute and kind of work through. I'll be available here if you have a question. I can, but just something fun and interactive, and it'll cover 11.1 and 11.2. Okay, so it'll be something fun we can do on Monday. All right. Any last minute questions before we go, guys? All right. Well, I'm here all day if you need additional homework problems or you have any other questions, okay? All right.
Okay.
Have a great day, guys. I will see you on
Thank
Monday.
you.
Thank you.
Thank you.
Thank you.
Bye.